Hello everybody, it's Mr. Martinez here, and what I'm going to do is I'm going to just cover, for today's lesson, I'm going to cover polymorphism. Now we've spoken about this before and coming up to it and what it means, and today I'm going to give you a brief description of what it is. So I'm going to separate my classes here. So what I have is, actually let me switch this one over here and see if I can, there we go. Perfect. So what I want to do first is I want to show you my current setup. I have an abstract class called animal. Now remember, with an abstract class, you cannot make an object out of it. My methods are abstract, which means they act just like methods in an interface. So that means if I ever inherit animal, I have to make sure that I initialize these methods right here. Okay, so I've done just that. So as you can see, I created a class called dog. Now, as you know, dog is a more specific type of animal. And as you can see, I have initialized the three methods that I needed to or were required to do by the abstract rules. So make sound, I just put woof, can eat, I put snarl, and get species, I put canine. Now, I also made another class here called cat. And this time I initialized them with meow, purr, and feline. But if you take a look, I also added a new method to cat, defend. Okay, so pardon the voices, but again, this is just to show you it's a combination of two things. One, I can, if it's a class, I can treat it like a class. I can make new methods. I can add variables. I can add a constructor. But two, it's going to show us something that we're going to need to know in polymorphism. So polymorphism, what we're going to do right now, we're going to head over here. Polymorphism is basically, I like to look at it as an organizational tool. It basically helps you keep things in line, and it's not that difficult of a concept to pick up. So as you can see, animal was the class that everything was referenced here. Okay, now this is an abstract class. Polymorphism works for regular classes, and it works for interfaces. So let's take an example. So animal A equals new animal. And you'll see right off the bat that I'm going to get an error. And the reason why is it'll say can't instantiate the type animal. This is an abstract class. So I've purposely made it so you cannot make an object out of it. So am I allowed to do dog A equals new dog? Let's take a look. Perfect. Why? Because I've made a dog object. Now I have cat down here. Can I say cat B equals new cat? Perfect. These two are fine. They're not abstract. They've initialized all the objects as required by the animal abstract class. Everything is good. Now, here's where polymorphism takes place. Let's say I have a whole bunch of species of dogs, okay, or types of dogs. Let's say right now we're just going to go with animals, but let's say we have, or let's just say we have a bunch of animals. We have dog, cat, hippo, lion, all these are not lion, but like reptiles, every different type of animal that you can think of. So what I can do is this. I can actually say animal dog, or animal, let's say C equals new dog. What I'm now capable of doing is I can do dog or C dot, and I can do either make sound, can eat, or get species. So if I do can eat, C can eat, and I run it, boom, snarl. So what's happening here is what polymorphism is basically saying is, okay, this is an organizational tool. This is the reference type. And as long as this constructor for this object has inherited from this reference type, everything's good. You can use the methods. Now, this reference type, again, can be an abstract class, it can be an interface, or it can be a regular class. Doesn't matter. It's as long as you have inherited it. What here is something that's not legal. I can't say dog D equals new animal. This is a no-no. In polymorphism, your reference class will always be on the right hand or on the left hand side, and your method or your constructor for your object will be on the right hand side. So if you ever see the reference type and it's abstract or it's an interface, it's a no-no. You can't do it. Okay? So let's take a look at cat. Animal D equals new cat. Boom. Okay, and let's do D dot make sound. Okay, this is great. Snarl and meow. As you can see, both of them are animal references, but they are completely different objects. And that's where polymorphisms takes into place. It's basically organization. Now, there is a term that I want us to take a look at, and that's called downcasting, object downcasting. There is a problem with polymorphism. Now, if I look at my cat object, you'll see that I made a new method, defend. Let's go back to this object right here. D.defend. You'll notice that, where did it go? You'll notice that I get an error here, okay? In polymorphism, you can access basically all methods that you have inherited from the superclass, okay? But new methods, in order to use new methods, an issue happens because you're no longer referencing the type. Your references are now null and void when it comes to new ones. So all the ones right here are legal, but this defend one, we've got to do something, and it's a type of casting. So what we have to basically do to use this new one is we have to basically tell the computer, like, hey, this is all legal. The reference, as you can see, works, but I've got to remind you that this is a cat object. So what we have to do is we have to cast it as a cat. And then, as you can see, here we go. Let's, oops, and somebody texted me at the wrong time. Okay, so as you can see, cat.defend works perfectly now. So if I run it, rar is right there. There it is. So this term right here is called downcasting. So again, what it's doing is when you have any new methods that you have created in an inherited class, and again, this only works for polymorphism. If you have referenced it like this, you need to make sure that if you're calling on the newly created method or the original method, that you cast it as a cat and you defend it. Now, as you can see, if it's just a regular cat equals cat, b.defend works fine. Okay, because you've directly created a reference out of it. Okay, as you can see, b.defend rar, and then snarl meow rar. So, as you can see, it works just fine. If it's just that. It's only when it's a new method being called from polymorphism. So, that being said, let's review some of the items that are important in this video. 1, I have the abstract class here. Okay. 2, I have my abstract methods. And what this means is 2 things. 1, this is a no-no. I can't make an object out of animal. And 2, whatever extends animal needs to initialize these methods. Okay? Then we move on to the extended class. I've initialized the methods. Here, I've initialized the methods, but I've added a new method. Okay? Nothing different. You guys know how to use extends. Everything's good. Now we go over to our tester class again. Dog A equals new dog. I've just made an object out of this. I can use the methods. Everything's good. Cat B, as you can see, everything works fine. I can even use a defend method. But right here, animal C, new dog. Here is my reference type. Here is the object constructor that I'm going to use. Does dog extend animal? Yes, it does. Everything's legal. Can eat was an inherited method. Boom, we're fine. Animal D equals new cat. So D is now a cat object. Make sound. Make sound was an inherited method. We're good there. But defend. The reference again, where it's used polymorphism. I can't use new methods unless I remind the computer that this is a cat object, which I'm doing with my cat cast right here. Again, this term is called downcasting. And then everything works fine. So again, this works with this right here. This reference type can be a class, it can be a interface, or it can be an abstract class. That is polymorphism in a nutshell, guys. I'm going to upload this right now. If you have any questions, feel free to email me, and your assignment will be on my Milken.